Project metrics are the project estimation program for projects already underway. You have a project, it's some distance into it, and the question is, how close are you to shipping? When are you going to be done? It's one of the most difficult problems in IT for the same reason as project estimation. The problem is that people collect metrics and say, well, yes, by these metrics we can tell how productive we're being, how much work we're getting done. One of the, and I really don't know how much this is still used, but I shake my head every time I run across it. It's lines of code. Well, we think this is going to be 100,000 lines of code. We've produced 70,000 lines of code, therefore we're 70% done. Trust me, there are large organizations that have used that. There are a lot of metrics that are used, not because it's like the story of the drunk who's lost his keys and he's under a lamppost looking for them, and someone says, what happened? I lost my keys. Where'd you lose them? Over there. Why are you looking here? Well, because the light's better. A lot of metrics have that logic. They are gathered not because they are actually meaningful, but because they're easy to gather. You can count lines of code with simple shell script. It, for the most part, has no meaning whatsoever, except as an after-the-fact rough idea of the complexity. But if you're doing proper refactoring of your code, or re-architecting, particularly with object technology and reconsolidating things, they'll have periods of time where the lines of code is going to shrink. And that's usually a good thing. But if you have management that's using lines of code to measure progress, heads are going to explode.
You scare them by minifying it.
Yeah.
Progress.
Now, here's a problem, is coming up with a metric that actually meets these three qualities. First, it has to tell you something meaningful, either informative or predictive. This is hard. I mean, stop and think. All of you worked on software projects, one kind or another, at the very least here in school, whatever. What would be, stop and think, you don't have to answer them. I'm happy to have people raise hands. What do you think is a good metric that lets you know how far the project is really done? Yeah.
I mean, it's not a perfect metric, but I mean, it at least indicates something. If you can, like for example, we went over the Gantt charts, just saying which of these have been accomplished and which of these have not sufficiently.
Yes. So there you've broken it up into modules. You say, yes, we think this module is done. Yeah, Dave.
And also, we talked about how sometimes with huge code bases, as you fix bugs, you get more bugs.
Yeah.
And if your bugs aren't stabilizing, that means that you're not making. You might be making progress, but you probably are not. And so, if your bugs are stabilizing, you're being able to close bugs, even if you're not implementing such and such module or piece of code, you're in the right direction.
Which is one of the ones I've brought up in previous classes. At Pages, the one metric we actually used during our last few months trying to get the product 1.0 out the door was the bug find rate divided by the bug fix rate. If we were fixing or deferring more bugs than we were finding, we knew we were on a path to shipping. Now the problem with that is that tells you you're going in the right direction. It doesn't tell you how long it's going to take you to fix those bugs. And of course, what you start doing is you find bugs and you start deferring more and more. Most commercial products are shipped with incredible numbers of bugs. You'd be surprised. Most because they just want to get them out the door. So it has to be informative or predictive. It has to be objective, which means it doesn't matter who's doing the measuring. In other words, the metric has to be one that is independent of personal assessment. And we'll talk about why in a second. And the third one, almost certainly, is it has to be automated. The problem is most project metrics lack at least one of those qualities. Some lack all three. But most lack at least one of those qualities, and so are flawed. Oops. Some laws of metrics. Weinberg, Jerry Weinberg, Psychology of Computer Programming. You should read it. Actually, read anything by Weinberg. He's written a tremendous amount, mostly about achieving quality in software. But anything he's written, I would recommend. I probably own 5 to 10 books by Jerry Weinberg. Actually, probably closer to 10 than 5. His law of metrics is that which gets measured gets fudged. When you have metrics that are being used, and there's a great book which I will bring into class on another future class, that basically provides a detailed philosophical and mathematical analysis of why management by metrics will almost always fail. And it's basically, the whole book is basically a formal proof of Weinberg's law. Classic example, and I may even have mentioned this, is that it has been repeated any number of times. Company says we have to fix bugs, we have to fix bugs, we have to close bugs out. We'll do a bug bounty. We'll pay, for every bug closed, we'll pay $25. Okay? Well, what you have happen is you have programmers who start introducing bugs, and QA people who start fixing them, and then they split the cash. Any metric which is being used as a form of, if you achieve this, you will be rewarded, or if you don't achieve it, you'll be punished, it will be fudged. Which is why we're back to the objective and automated. And informative. In other words, the metric has to be important, it has to be objective, it has to be automated, because otherwise people will find ways to game the system. The metric law of 90s, to make things look good, we will often focus on low-hanging fruit. We'll get the stuff done that we can get done quickly. We've already talked about this rule. First 10%, 90% takes 90% of the schedule. Remaining 10% takes the other 90% of the schedule. This is sort of and the reason for that is a cross between Brooks and Armour. That remaining 10% is usually testing you failed to account for that you're going to have to do, and discovery that you pushed off. And so you get to, anytime I hear someone say, oh, the project is 80% done, how do you know? Based on what? And they're almost always wrong. I hate to put it that way, but they're almost always wrong. Unless you have a predictive, automated, objective metric that says, we know every time we get to this stage of the project and we use these metrics, we know that we are 80% of the way through the schedule. Do that, I might listen to you. Yeah?
And that's the benefit of having all the test cases for the program written before you write the program.
Yeah, because here are all the test cases. What that doesn't do is that you'll have discovery about things like, oh my gosh, we also have to do X, Y, and Z. This is sort of the Damocles that's hanging over the Moa group with bit chains, or blockchains, excuse me. It's kind of like, well, we're going to do this, but we're probably going to have some really unpleasant discovery halfway through this project and say, oh my gosh, this is just not achievable. And you guys should be planning for that, by the way. In your project, you should actively plan for reaching a point and saying, this literally is not achievable in this time frame. Here's what we're going to do. We're going to turn this into a research project. Here's the information you need. Here's what we've discovered on using blockchain. And by the way, that's a whole other discussion which we will have later on. Organizations do not plan for project failure. They assume every project is going to ship successfully. Even though, once you get above a certain level of size and complexity, 50% of all IT projects fail. And one of my pet hobby horses is that a big problem in most organizations, particularly organizations that do large-scale projects, they don't pull the plug fast enough. They keep hoping somehow it's going to work, and they pour millions, sometimes tens or hundreds of millions, occasionally billions of dollars into a project that an independent assessment would say, no, this is already a disaster. Yeah.
You use that statistic for a failure. What kind of failure do you mean? Like any type of failure, like customers don't want it, or technological failure?
Usually a failure meaning we finally abandoned the project because it was so far beyond schedule and so far above budget, and we didn't have anything to put in production.
Gotcha.
So, but that's a very good question, because there are some stats will have failure as being more than twice the schedule or more than twice the budget or whatever. So it'll be a failure of planning and estimation, even though the project may go into production. Some will base it on it went into production and the benefits expected were gained. So yes, it's always good to look behind it. Yeah.
You said after it's passed, 50% of projects fail after they're past a certain size and complexity.
Yeah.
How big? And like, how do you measure the complexity?
Usually it's measured in terms of function points, occasionally in lines of code. If you're looking at, let's use a dollar figure. If you're looking at projects that are on the $5 million level and above, the rate of failure is probably about 50%. You'll get different statistics from different places. I actually have some papers I can cite and put out there for you all to read on those, because I go through this. Again, a lot of my work is as an expert witness in failed IT projects, and my analysis is like, here are all the known causes. Here's a typical arc of a failed project. Let's look and see what happened each step along the way, and did this match up, and who did or failed to do things. Metric law of least resistance. This gets back to automation. The more human effort required to calculate a metric, the less often and less accurately it will be calculated until it's abandoned and ignored altogether. Hence the joke about the trunk with the keys. And contrary-wise, a lot of metrics are used because they are easy, not because they're informative, such as lines of code. I can write a little tiny script and it'll just go through and count. And if I get a little more sophisticated, I'll drop out all comments and just have actual lines of code. And I'll drop out blank lines, and by golly, I actually know what this program is doing, because here's our growth week over week in terms of lines of code. Why is project completion so hard to predict? There's a little diagram there. Basically, there's a problem. You started, you're at a current spot, you're hoping to end at some point. Why can't you just look at the project and say, hey, this is it. Look at the list of factors. We have talked about just about all of these. The amount of analysis that still has to occur. It's possible to get well into a project and still have unfinished analysis. I mean, I'm not picking at you guys, but moi, okay, it's kind of like we're still trying to figure out some of this stuff. The amount of invention. This is armor again. What invention? There are problems. Not only are there problems that you may still have to come up with solutions for, there may be problems, discovery, that you don't know about yet. And this happens in particular because we tend to do the easy stuff first, we defer the hard problems, and we get to that, oh, we're 80% done, we're 90% done, and suddenly you're dealing with half a dozen hard problems which have some mutual incompatibilities in their obvious solutions. It's like, oh my gosh, we actually have to invent something entirely new here to get this done. The adequacy or the inadequacy of the current architecture, design, and implementation. In other words, you discover that what roadmap you set out for yourselves isn't really trending toward a solution. Predicting the amount of actual coding that has to occur. Coding is a highly intellectual effort. If I have to write something, there are sort of two types of coding. There's the coding where it's like, I have to put this up on the screen. I've got to get this done. I may have to look up some APIs and tweak with this and so on, but it's sort of like laying bricks on a wall. Then there's coding that's the effort of, let's see, I have to do a footpath that goes from here 100 feet over to the other side of the river, and it has to withstand 100-mile-per-hour winds. And you're suddenly having to go back and do some serious invention, possibly achieving things that people haven't done before, because, again, as per armor, if you're simply doing what everyone's done before, the value is much less. It's the breakthrough. It's like, you know, how many of you, and again, you know, I'm a gamer, how many of you boot a program, particularly a game, and start playing, it's like, wow, how did they do that? You know, trust me, I've been going through that for 40 years. Like, that is so cool. I wish I had thought of that. That's where a lot of the value comes from. So, you know, sometimes it's you know, putting bricks on a wall. Sometimes it's real true invention. The amount of quality engineering, and we're going to talk about that in a few minutes, that still has to occur. And we're back to Brooks. You know, claiming 50% of the schedule is devoted to testing, not because they planned for it, because that's what they actually spend doing. Any and all external dependencies. In other words, you may be waiting on something from someone else outside of your firm that you have no control over, and that's just not showing up. The talent, experience, productivity of your IT engineers and managers, as well as turnover among those employees. You know, you may have, most of your team may be working well, but you've got some critical part, you've got a developer working on it, and he's not getting it done. And it's kind of like he's not getting it done because this is a really hard problem. He's not getting it done because he's just a bad programmer. The amount of business process re-engineering required to put this into production. This is something in a business environment. Now it's the end users. Remember the negotiations and love songs. The end users. We don't like this. It doesn't work just like the old program. Well, the old program. I know of a project. I kid you not, where an old legacy application was being replaced by a brand new modern technology application. And there were end users who were unhappy because in the old project, it would only type uppercase. So if you're it was filling out forms, like it was for, basically it was a personnel placement system for medical personnel. And they had this old Unix-based app, and it did everything in uppercase. And J.D. Edwards came in, was doing this brand new, you know, modern technology, yada yada. And the end users were saying, well, we want all the text to be in uppercase. They said, well, you can press your caps key. No, we don't have to press our caps key. It shouldn't matter what our keyboard settings are. It should do it all in uppercase. And it created headaches because it was supposed to generate letters and all the data was stored in uppercase. And so suddenly you had letters where the name was all in uppercase. Dear Bob, you know. So never underestimate the ability of end users to sabotage your system. Complexity, cohesion, and comprehensibility of the overall system. And other factors, scope creep, conflicting requirements, change in business and market needs. You have a project, you get, you know, 75%, mythical 75% through it, and suddenly someone's just come out with a brand new competitive project that leapfrogs it, and yours is sort of dead on arrival. What do you do? You know, do you suddenly restructure? Do you suddenly say, okay, we have to catch up with this? How are we going to do this? Okay. My solution to useful metrics is actually based on work I did at General Dynamics. Not with metrics, but with side-looking radar. I was the programmer. I was working with a radar engineer on a project back, we're talking 1978, okay, 79, depths of the Cold War. Soviet Union had what was called the Iron Curtain, cutting Europe in half. Eastern Europe was controlled by the Soviet Union. And they had forces lined up all there to basically invade Western Europe. But they only had so many tanks, but they wanted to make it look like they had tanks everywhere. So they devised plywood shells that they would put over trucks. And so they would have this, if you'll forgive the term, this shell game, where they would have trucks and tanks spread evenly all over the border between Eastern and Western Europe. And basically, you know, either high altitude airplane or satellite pictures would look down and they'd all look like tanks. So this engineer at General Dynamics I was assigned to work with, had this idea. There's standoff radar, side-looking radar, that would bounce, that would be, say, 30 miles away from the border and would be scanning all these vehicles from the side and would get back a radar signal. And what we did, how many have had stat? We do Bayesian analysis of the characteristics. There were like 26 characteristics of this radar signal coming back. And we do Bayesian analysis to see which combination of characteristics had the highest rate of distinguishing between a vehicle that had tracks, a tank, and a vehicle that had wheels, a truck. And we found with 3 characteristics, we could get 95% separation between the two. I don't know if they ever went on. I just did the coding, coded up the stuff, did the analysis, and so on. So, proposal here is take a project, probably a pilot project or a small and important one, and collect all sorts of automated, independent, objective metrics on it. And then go back, after the project's completed, and do analysis and say, which combination of these metrics gives us the most accurate sense of what we now know where the project was at that point. So you have instrumentation to collect all of it, and then you apply heuristics, Bayesian analysis, human analysis, and basically try to do it. Now, no one has paid me the money to go and try and do this in projects and see whether or not it works, but this is my idea. That's it on metrics. Any questions? Comments, observations? Hang in there. We're almost done for lectures. I know it's hard. Okay. Trust me, I'm not offended when you yawn or doze.